Hello everyone, and welcome to this SOLIDWORKS 22-minute webinar, Building a Better Machine. My name is Cliff, and I'm going to be your host, and we're going to jump right in and get started as we have a lot to cover in a short amount of time. I want to introduce our presenter. Craig Therian is the product manager for SOLIDWORKS. He has over 25 years experience in 3D CAD, started his work experience in aircraft engine design, manufacturing automation, product management, and 3D CAD implementation. He has been with SOLIDWORKS for over 10 years now. With that, Craig, it's all yours.
Cliff, yep, thank you very much, and welcome everybody to Building a Better Machine. And I think the first thing that people always ask is, well, what do you mean by that? What do you mean by building a better machine? So, you know, a lot of people look at machines. By the way, machines are different to different people, right? You get machines that are, you know, things like agricultural equipment, you know, heavy machines, heavy equipment. You get machine tools, packaging machines. Vending machines, Coke machines, they're machines, you know. So machines cover a wide array of different types of products that are on the market today. But one thing that's very similar is the way that they are designed, the product development processes, and even a lot of the parts that are used in those products, the types of things, and it's very similar. So this webinar covers a broad array of products that people design. So basically, if I look at what is a better machine, maybe I'm looking at better performance or throughput, something that's more reliable, less maintenance, or even connected to the internet might be a better product. More flexible, more modular, more configurable. You hear that a lot in the packaging industry especially. Something that can be designed for a better price, less expensive to manufacture, so it's more competitive in the market. Or maybe something that I need to be able to design quickly, turn it around, and get it to the customer quickly. Like in the oil and gas industry, that's a big demand. Is I need to be able to make it quick, get it to manufacturing, and get it to the customer quickly. All right. So you know, looking at this, better machines. You know, what does that really mean to people? What can we do at SOLIDWORKS though to help you? Well, one thing we can do is provide you better tools to help you get your job done. And when I say better tools, not only like faster drawing and quicker annotations and things like that and better features, but it's also extending SOLIDWORKS into different areas, things that we weren't known for originally in just design, kind of parts, assemblies, drawings, but extending out into electrical, into manufacturing areas, you know, places like that. And that's really what I want to talk today about. How can we help you improve your product development process by new tools that are available, or some of these older tools that people just don't know about that are available in SOLIDWORKS. So let's start off by looking at a typical, what I call a serial product development process. Okay. So for machine design, a lot of times you're starting with your conceptual design and maybe schematics even. You know, what are the main systems that are going to be in my machine? You at some point start your mechanical design. You're reusing parts maybe from older designs. You're using maybe data management to find that information, starting and reusing some of that information. Then you get into integration, and typically we see in a serial process, mechanical design is done, and then it kind of goes off to the electrical and controls people, and they're running wires, they're figuring out what the sensors are, they're figuring out what motors are needed. Final documents are created. Those may be BOMs and ordering and things like that. Goes to manufacturing, and that would be creation of NC data, possibly, toolpaths, inspection, technical publications, shop floor instructions for assembly, and then finally, once all that's together, you can actually start your production runs at that point. Now, there's a lot of things I left out here, right? Like iterations of designs, prototyping, and things like that. Those are going to take up more time, obviously. So how can SOLIDWORKS help improve this process, right? So let's look at a way that we can help. Well, basically, by taking that serial process and making it more of an integrated process, we're able to work concurrently. We're able to actually compress the cycle, save you time and money, all right? And we call this a concurrent and integrated product development process. So in order to do this, you need certain tools in SOLIDWORKS so that everybody can work on the same system at the same time, all right? In addition, a concurrent process allows you to make better decisions earlier with more efficient, parallel, and iterative processes. So even if you do outsource, right, if those people that you outsource to have SOLIDWORKS or have some of the other tools, SOLIDWORKS Electrical, some of the other tools we'll be talking about, they can still be part of this integrated process even though you're outsourcing. So let's look at the first part, improving mechanical, electrical, and controls integration, right? So why is that important, okay? It's important because SOLIDWORKS customers design large, complex machines, all right? Packaging equipment, even like you see a plant, right? A plant that processes materials, processes concrete or recycles materials. A plant is a massive machine, if you think about it. It has machines, it has conveyors between it. That's an incredibly large machine, okay? So changes are difficult and expensive to make once you've built it or once you've started going down the manufacturing process. So if you find at the end you've built your machine and it doesn't meet your throughput requirement, what do you have to do? You have to dial that machine back, right? You have to slow up the throughput. So your estimate of 500 parts a minute now becomes 250 and your customer isn't going to be happy. So doing the analysis and doing that stuff up front will help to make sure that when you build the part, it's right the first time, or build the assembly, it's right the first time. Larger complex systems are hard to control. You want feedback and understanding of machine dynamics, right? So again, at the end of the design, when you're done and you're doing your final prototyping, well, that prototype's going to be shipped. All you have now is the ability to tweak it, all right? So if you could do some analysis up front, that would help. And what we call this is more of a mechatronics approach, where you're doing your analysis of the system up front, you're tying it in with electrical, and you're able to do your controls programming, just after, even before manufacturing has started. Okay, so what's the challenge? One of the big challenges, now I can't cover everything, we've only got a limited amount of time here today, so I wanted to cover one of the things that I see as being one of the biggest problems between communicating the design between the mechanical design to the electrical people. So how do you communicate, like, this is what my machine does, right? So you want to tell people, how does it work? Now, a lot of times I see people actually using 2D drawings for this. They create a 2D drawing, they go into a meeting room, and they say, okay, this part right here moves over here and then it hits this thing over here, and then this thing moves down here. I see that level. The next step up from that is if people make a motion simulation, right? So traditional time-based motion simulation. So it'd be, something like this, right? A time-based motion simulation. Now, these are great. These are, they show exactly what's going on. And you typically, when you do these, you're setting when you do a traditional motion simulation, it's time-based. Okay. So here's another one right here, right? Now these are great. These time-based simulations are great for simple motion. So if you're doing hey, here's how the mechanism works or something like that, they're pretty easy. But the problem is when these things get very complicated, like this one here, when you have multiple things happening at once and things are being triggered and there's sensors and things like that, proximity sensors, large and complex systems are hard. They're hard to program with a regular time-based motion. So what's your alternative here in SOLIDWORKS? Well, back in, I think, 2009 we introduced event-based motion. And this one came out from a lot of studies we did with customers, even with some of our partners like Rockwell, actually, where we found out that a lot of customers had problems communicating what the machine was doing to the people downstream who were going to be selecting the motors, and they were going to be programming the PLCs and things like that. So all of this information can be captured in a better way, much better than time-based. And that's where event-based motion comes in, okay? So let me just play a little video here. So event-based motion lets you not only set time, but lets you set, as the name says, events. So you can say, hey, I'm going to set a sensor when my product, when that edge of that pallet is within 10 inches of that other face there, I want to trigger another event to happen. So by setting that analysis up, you can actually see there is a time-based version of it that you can see, but then you can also switch over to what's called the event-based view of what's going on. All right. So here you can go in and change the event-based information. You can change the time. You can move things around. You can actually add new events that are going to happen. And as you do that, your time frame-based information is going to update automatically. So very quickly, I can set up the motions that are required on this conveyor system. Okay. So you see the difference between time-based, where you have to set everything up in a time sequence, and event-based, which allows you to determine sensors and events and triggers, and then automatically output a time frame system. Okay? So as you get more and more events or more actions that happen, this problem grows. It gets bigger and bigger and bigger until you get into these massive machines with hundreds and hundreds of actions that happen. And this is really where you need to have event-based motion to help define these motions, so you can communicate them more clearly to your electrical controls people, but also to your customers, right? It's a great way to communicate with your customers. So look for event-based motion. Again, this is really built from input we got from machine builders. When traditional simulation, motion simulation will cut it, right? Time-based motion will cut it. You get event-based, and it lets you do time, events, and lets you add sensors, okay? So key functionality, you can simulate machine tasks, and you can optimize cycle times. You can create event triggers, all right, that you can show the start and end of a task. Servo motors control the actions. You can have proximity sensors, like we showed in the video there. And you can create Gantt charts, and you can also output to Excel and export all this information out to Excel. So again, event-based motion, it's in Simulation Professional. Check it out. It may be something that will really help you to communicate better to other departments in your company and also to your customers. And for yourself, it's a great record of how the machine is supposed to work. And of course, if the model updates, all the other information will update accordingly. It's always parametric, right, in associative. Now, I also wanted to touch on what people talk about mechatronics design, right? So a couple of our partners, specifically Rockwell Automation and also National Instruments, have developed kind of plug-in solutions that work off of the SOLIDWORKS information, like reading in values that you've set up for motion simulation, read those values in automatically, and make decisions, for instance, about what size motors you want to select, for instance. So we've got Rockwell Automation with their Kinetics Motion Analyzer, LabVIEW, National Instruments with Soft Motion for SOLIDWORKS. So again, I'm not going to get into a lot of detail on that, but these are two products that you might want to look into to help you improve the communication to the electrical and controls people. Okay. What else is challenging when it comes to designing your machine? Well, integrating electrical design, right? So, when you wanted to do schematics before, how did you do it? Now, you probably used like a 2D tool. You might have even used like Visio or something like that. Well, SOLIDWORKS in 2013 introduced SOLIDWORKS Electrical, which gave you the ability to do 2D schematics. Then we allowed schematics that actually link the 3D models, all right? So now you have the entire process where from the schematic you can be linked to your 3D models. You can auto-wire and auto-route things like control boxes, control panels for machines. So there's some great new functionality that we've added for SOLIDWORKS Electrical. So we've expanded the collaboration between schematic and mechanical design. You have a wire and cable harness. Instead of it just being in SOLIDWORKS, you can actually manage it from outside. You have automated manufacturing drawings, so flattening and also wire routes. Intelligent reports. So there's ways that you can do incorporate design rules, electrical design rules, to ensure that you're not violating these design rules. And then, of course, in general, you're merging what used to be just a separate piece of software, 2D schematics, with 3D models. All right. So what can you do? So you look at a typical design, a typical machine design, and under the covers, though, there are sensors, there are wires, there's cables, there's control panels, there's all this other stuff that goes on. So really, a complete machine design is the accumulation of not only the mechanical side, but of course the electrical side too. Okay, so, oops, sorry about that. So what is specifically for machine design, what are we looking at? We're looking at 3D cabinet design, all right, these areas. Makes that much easier with electrical. Electrical, you do harness design and controlling your wires, where they're going, laying out of your harnesses. And of course, if you look at the whole system, you know, how has the product development process changed if you use SOLIDWORKS and SOLIDWORKS Electrical? You've added all these capabilities. You can do your planning. You can do your panel layouts. With CircuitWorks, too, in SOLIDWORKS, you can bring in PCB information. It actually will update. It actually reads back and forth to your electrical systems. Of course, I think a lot of people have heard of PCB Works. SOLIDWORKS PCB Works is coming online, which is powered by Altium. That's going to be out in a few months. And then you can also take all this information and you can get it out to manufacturing. So in the end, also technical documentation, right? All this stuff can be read in eDrawings now. That's an update, recent update. So eDrawings now also reads your electrical information, all right? So through your whole process, now you can tie your electrical all the way from schematics all the way to final delivery of your documentation at the back end. So this is really look at SOLIDWORKS Electrical, look at the capabilities, see if you can make improvements in your product development process, even with the people who are in other groups, to see if this product could help to improve your process. Okay, next I want to talk, we talked about kind of how do we improve the link between design and electrical and controls. Let's look at how we can improve from mechanical design. Let's look at how we can improve from design to manufacturing. So I like to call the SOLIDWORKS products combined with all our partners on the outside. We have a lot of CAM partners. They're fully integrated. We have a lot of gold CAM partners. We have progressive die partners. We've got mold partners. We've got a lot of people that really specialize in certain areas. Sheet metal design, sheet metal nesting and manufacturing, right? There's a lot of products out there. Check out our partner website, all right? I really, really advise that. Look what's in there. Look at the partners that are fully integrated with SOLIDWORKS, okay? So these products allow you to not only send people a SOLIDWORKS model, but if you make changes, their information can update automatically also, right? Like a toolpath can update, that type of thing. So we call all of these things that we do downstream, we call them a manufacturing ecosystem. All right, and if you look at a few here, right, some of them are internal to SOLIDWORKS, assembly docs and inspection documentation and cost estimates and checking for plastic simulation, for flow, for your injection mold. Flattening, I don't know if people have seen that. That's a great new feature. It's been radically improved for SOLIDWORKS 2016, so you can create flat patterns. So if you have parts that can't be flattened, you can use that functionality. So there's a lot of stuff in here. I'm not going to be able to cover all of it, so let's look at a couple of key things, a couple of key time savers that are out there. So the first one I wanted to talk about was actually SOLIDWORKS costing, which allows you to hit that target for your cost for your assembly, and that's a key thing, right? A lot of people now have a target cost for their machine designs, whether it's from sales or it might be from your marketing department. They, you know, what they call a marketing requirement document says the cost of this thing should be no more than $20,000 to the customer, you know, that type of thing. So what we've added to SOLIDWORKS since 2012 is the ability to automatically do a cost estimate. It doesn't really require you to do any extra work. Like you see here, you click a button and it actually tells you how much the part costs. Well, we've expanded that to include also assemblies now. So you can do parts and you can do assemblies. So you can just kind of check the cost of your part. We've also, for the sheet metal side, we've added sheet metal nesting to give you a more accurate cost for the amount of material you're using in 16. So, and also outputs reports, cost reports. So this is a great way, costing is a great way of looking at your design, trying to figure out, getting kind of what I call a should cost on how much it should cost to make your part, and then saying, how can I take cost out of it? You know, I've had people be as radical, and we've also added, by the way, the ability to do frames, weldments, Okay, that came in 2015. It's been improved in 16. So a lot of machines have frames, right? So how can I take the cost out? I had one customer went as radical as to get away from using extrusions, and he went to doing his frames from sheet metal, right? So he's able to get the material faster because everybody has sheet metal in stock, and he's able to make basically a unibody. Think of cars used to be on frames, right, and now they're unibody designs. He was actually able to make his machine cheaper, lighter, and actually more rigid, amazingly enough. So, you know, look at some of these alternatives and look at how much it's costing you. Make sure you're hitting your cost target. SOLIDWORKS Costing can help you out. All right. We also have added in 2015 SOLIDWORKS MBD. Now this is a great new tool that allows you to, instead of using a 2D drawing, and there's a reason why we're doing this downstream. Instead of using a 2D drawing, you can dimension and tolerance your model in 3D. All right, that's what it means, model-based definition. But beyond just putting dimensions and tolerances on your model, you can also save views and views along the bottom. So really, it's really like a 3D drawing. That's how I like to look at it. So when you get into a certain view you like, you say save that view. And then you can click back to that view whenever you want. So I'm going to let this play out here. And you can see how when you go to a view, it's just like in a drawing. You only see the dimensions you want to see. It automatically hides all the other dimensions behind the scene. All right? So you're able to pick edges just like you can in a drawing. These dimensions that you're placing, by the way, you can do basic dims now too. And you can also do assembly level dimensions, which you weren't able to do in 15. So you can do that in 16 now. So here's an assembly, and you're able to do assembly level dimensions. So there have been radical improvements in SOLIDWORKS MBD, drawing it much closer to everything that you can do in 2D drawings, but you're doing it in a 3D environment. Now, why is this important? Because a lot of customers are asking for 3D models with PMI. They call it product manufacturing information. That's model-based definition or model-based engineering. All right, the government's asking for it. I know a lot of mold makers have gone that way, or a lot of people who deal with plastic parts have gone that way because they just don't have the time to make the 3D drawing. So if your process is used to sending parts along, where you send the part to manufacturing and you also send a critical dimension drawing before the actual drawing is done, you guys are right in line with what MBD is all about. Instead of putting the dimensions in a critical dimension drawing, put the dimensions directly on the 3D model. All right, that's SOLIDWORKS MBD. You can also output. Okay, so the problem with model-based definition or putting dimensions in 3D in the old days was that there was no accepted vault format. There was no, you had to save it as a SOLIDWORKS file, or you had to save it as a Pro-E file or a CATIA file or whatever, right? But now this is a government-sponsored and standard-sponsored capability. Inside of PDF, there are standards now that tell you how PDFs are supposed to react when you have a 3D model in them. So now you can create a quote-unquote 3D PDF. It's not really the extension is the same. It's a .pdf, but it has a 3D capability inside. It's very much like an e-drawing, right? Except this is a PDF format that, you know, basically, as the government says, will last for 99 years. In other words, they'll be able to open up that file 99 years from now. It's called LOTAR, which is long-term storage, long-term retrieval and storage or whatever. So you'll be able to retrieve these documents on into the future. Most people right now, their final document is a PDF anyway. Why not look at doing this as a 3D PDF where all your views, all your dimensions, and all your notes are added automatically to the PDF, and you can also customize the PDF to create whatever you need. So this is a quick way to get to manufacturing without having to create a separate drawing. You just output directly to the PDF. All right? So that's MBD. Now, what's the advantage of MBD downstream, right? How does this help me do things faster? Well, if you look at our CAM partners, they read SOLIDWORKS files directly, all right? So if you put the 3D dimensions in the SOLIDWORKS file, as they're creating the toolpath, in this example is CAMWorks, right? But as they're creating the toolpath in that partner product, you'll be able to see the dimensions and tolerances. So that's step one of integration. But there's even something better, all right? So look at this. So as an example, CamWorks just came out with the ability to not only see the dimensions and tolerances, but to make manufacturing decisions using the dimensions and tolerances. So here I have a triple tree from a motorcycle, and if you look, that hole is being drilled, it's being center drilled and then drilled, okay? Because the tolerance isn't very tight. But now if I change the tolerance, this is the MBD part of it, right? You're in SOLIDWORKS, you change that tolerance, and then I say, give me the new toolpath, all right? I'm going to update my toolpath. When you give me the new toolpath, you're going to see that the tool path has actually changed. So CamWorks says update my toolpaths, and now instead of just drilling, it's going to drill, ream, and bore because that tolerance got tighter. So this integration of having the dimensions and tolerances of the model downstream allows you to automate manufacturing processes. Now there's also a company called Origin, who's a partner, who automatically can CMM program based on a SOLIDWORKS model with PMI. So Origin has a product called Checkmate for SOLIDWORKS. It allows you to create an automatic CMM program if the model has 3D dimensions and tolerances on it. So again, massive change in the way people can do manufacturing. You can start to really automate the design through manufacturing process that way. So look into these products. CamWorks, CamWorks also has, they have tolerance-based machining, and they also have something called machine to the mean, which means that if you have imbalanced tolerances, if you have a tolerance that's +0, -10, that's a nightmare for manufacturers because they always have to model. They have to create their models to the nominal, so they cut to the nominal. So what CamWorks has done is actually use the PMI, use the dimensions and tolerances from SOLIDWORKS, and they've automatically offset the toolpaths to take into account what the true nominal would be for machining. So it automates that whole process, speeds it up tremendously downstream. So there's huge advantages, especially for people who are doing design and manufacturing internally, to speeding up manufacturing using these techniques, using MBD and then these downstream products. Okay? SOLIDWORKS inspection, we've had that since SOLIDWORKS 2013 now. It's a huge seller for SOLIDWORKS. It's actually our fastest growing product. If you have to go in and balloon your drawing for inspection, and then create inspection reports, or if you send that model, those drawings down to your inspection department, and they have to balloon them and create inspection reports, you can literally take out 80 to 90% of the time it takes people to do that, and you can be fully integrated. So just to look at how this works, you got a drawing, you can automatically go into the drawing and you can balloon note different requirements. You can also use this for existing PDFs. This is the standalone version of SOLIDWORKS inspection for PDFs. So if you have PDFs or if you have SOLIDWORKS drawings, you can use SOLIDWORKS inspection. Here was a really cool use case that a company called Holly in Germany did, where they've actually used SOLIDWORKS inspection to show exactly how the customer or how their inspection department should be inspecting the part. And once you inspect it, it reads in that information. So again, downstream, reusing the SOLIDWORKS data downstream to automate downstream processes. All right?